Hey pre-calc, welcome back. Our objective today is going to be to use the binomial theorem to expand binomials. I've got the checklist on the screen. You know what to do from here. All right, so on the screen, I've got some binomials expanded all the way. In other words, if you were to FOIL all this out, combine like terms, this is what you would get. And our goal for today is going to be able to expand these things rather quickly, as opposed to, say, if I gave you x plus y to the fifth, writing that out 5 times, foiling, combining like terms. The goal is, can I get here in like a step or two, as opposed to like 10 steps. So I'm going to force pause on the screen, see kind of what patterns you notice, anything you wonder, and then hit continue when you are ready to talk about some patterns. All right, we are back. So hopefully one thing you're noticing is that your powers on your x terms start at your degree, right? Let's take like this example. So x starts with my degree of 2, and then it goes down by 1 each time. So this is technically x to the first, and then this is technically x to the 0 power. Your y's go the other way around. They start at 0 and work their way up to whatever the degree is. So I have y to the 0, 1, and then 2, right? If we look at this one, again, my x terms start with the power of 3, and then they go down. Here's x to 3, 2, 1, and then 0, right? And y's go the other way around. Y to the 0, 1, 2, 3, okay? So those parts I think are fairly predictable. What's going to go on with, in this case, my x and my y. But what about our coefficients, right? Like here I've got 1, 2, 1. Here I've got 1, 3, 3, 1, 1, 4, 6, 4, 1, right? So we've kind of got the pattern figured out, I think, for x and y. Now I really want to look at this pattern for the coefficients. All right, before we get there, I want to review just a little bit of combinations. And force pause on the screen. Can you copy what I have? All right, so remember there's 2 ways to write combinations. You may see it like this: 8 choose 2, and that's where we have 8 factorial in the numerator. And then in the denominator, we have 8 minus 2 factorial as well as 2 factorial. And we could put this in the calculator. We could do it by hand as well. 8 factorial is 8 times 7 times 6 factorial. 8 minus 2 is 6, so that's 6 factorial. And then we still have the 2 factorial, right, which is 2. Okay, so if we divide out here, those become 1, 2 goes into 8 4 times, and 4 times 7 is 28. And force pause on the screen, try the next one on your own. This is 10, choose 3. All right, we should have gotten 120. If you did not get that, you can pause the screen and correct. Some notes I want you to be mindful of. 0 factorial is 1 by definition, okay? So will you write that in your notes, please? 0 factorial equals 1. And do remember that we can do this on the 84 using the probability submenu under math. All right, so we're still trying to, again, get to like how are we getting these patterns, right? And we're almost there. I'm going to talk to you about something called Pascal's triangle. You don't need to write anything yet. But Pascal's triangle goes like this. On the very top of the triangle, you have 0, choose 0, and that's called row 0. The next row, it's called row 1, is 1, choose 0, and then 1, choose 1. Row 2 is 2, choose 0, 2, choose 1, 2, choose 2, etc. So let's find some of these. Let's find some of these values. So 0, choose 0, by definition, that's 0 factorial over 0 minus 0 factorial times 0 factorial. And 0 factorial was what again? That was 1. So I've got 1 over 1, which is 1. So I'm going to take this and replace it with a 1. Okay. All right. Let's do the next row. So 1, choose 0. So I have 1 factorial over 1 minus 0 factorial. So 1 minus 0 is 1, and then 0 factorial. And all of those are all what again? Those are all 1s as well. So I'm going to replace that with a 1. Same thing here. 1 choose 1, you're going to get So you can try it, but you'll get the same exact thing. Okay, so far not so interesting about ones, ones, ones. You are going to get the same thing if you do 2 choose 0. Let me show you, because you're going to have 2 factorial over 2 minus 0 factorial times 0 factorial. This will be the case anytime you have like n choose 0 or n choose n, you're always going to get 1. So if you'll notice, like both of these two, I can replace with 1s. And same for these, so anything on the outside. And I just did the first 4 rows here, rows 0 through 3, but we're going to extend here in just a bit once we see a pattern. Okay, let's do this one. Let's do 2 choose 1. Let's see if we get something more interesting. So I'm going to have 2 factorial in the numerator, and then 2 minus 1 factorial, so that would be 1, times 1 factorial. So now I'm getting 2 over 1, which is 2. So for this term here, I have a 2. Okay. All right, let's do 3 choose 1. So I'll have 3 factorial in the numerator, and then I'll have 3 minus 1, which is 2, that factorial, and then 1 factorial as well, which is just 1. So basically everything cancels except the 3, right? Because this is 3 times 2 factorial. So this will be 3. Okay, you're going to get the same thing here. You're going to get 3 again. So these are rows 0 through 3. The next row, and I'm going to write it. Let's see if you can find the pattern. We know the outside is going to be 1. This is going to be 4. This is going to be 6. This is going to be 4. And then, of course, this is 1. Not thinking about your combinations here, like 4, choose 2, whatever. Do you see a pattern start to emerge? Hopefully you are seeing that if I pick an inside number, it's going to be the 2 diagonals above it added together. So for example, 4 is 1 plus 3, right? 6 is 3 plus 3. 4 is 3 plus 1. Okay, let's try to write the next row. So I've got a 1 on the outside always, and then I'm going to add these two together. So 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then a 1 on the outside. Why do we care so much about these? Let's take a look at that first screen again. Look at this row here. What are your coefficients? 1, 5, 10, 10, 5, 1, right? If we come back here, 1, 5, 10, 10, 5, 1. And that was row 5 because this was row 4. And this is row 5. Okay, so we've got what we need now to expand these binomials, because we figured out what happens with our x's and our y's, and now we know our coefficients. Whatever our degree is, we can just go to that row in Pascal's triangle and grab those values for our coefficients. So we can either use these creating Pascal's triangle, or remember we can use a combination. Okay, so I'm going to force a pause on the screen. Let me get rid of all these and go ahead and write at least through row 4 in your notes so that you kind of start to see that pattern emerge. Hit continue when you're ready to continue. All right, so again, if I want to expand something, a binomial to the 4th power, let's just in general call this term the x term and this term the y term. Again, your x's start at that power of 4 and move down. Your y start at that power of 0 and move up. Your coefficients come from Pascal's triangle, or you can also use the combinations on your calculator, right? So here's what I'd like for you to write. The coefficient of x to the r, y to the n minus r. So n is your degree. For example, the degree of this is 4. It is going to be n choose r. and choose n minus r. It's going to be, you get the same value either way. So can you please write this statement in your notes? Hit continue when you're ready to continue. All right, so let's actually try some expansion. So we're going to do x plus 4 quantity cubed. And remember, we could like write that 3 times and FOIL, combine like terms, but that is going to take a lot of time, and things that take a lot of time, then we're also prone to more errors, right? So we're going to try to streamline this and get to the result a bit faster, right? When we expanding things, it really helps us in calculus. It makes the differential and even the integral calculus easier. So we've got this. Now, instead of x and y, we've got x and 4, right? So x, this first term, is going to start with the power of 3, and then for each term, its exponent is going to work its way down until we're at 0. And then the 4 is going to start at a power of 0 and work its way up until we're at what power? At a power of 3, okay? Now, that's going to be kind of our non-coefficients, if you will. Now, our coefficients, we're going to grab from Pascal's triangle, row 3. So for that, row 3 is this one here, the 1, 3, 3, 1. So those will be our coefficients. All right, let's try it. So I'm going to grab my coefficient from Pascal's triangle first, and let me just write that row down. It was 1, 3, 3, 1. So I'm going to grab the 1, and then, I'm going to cross it off here because I've marked it. I'm going to start with my x with the power of 3, and my 4 with the power of 0. And I know 4 to the 0 is 1. I'm just going to write it all out and then clean it up in my second step. It's still a lot faster than all that foiling, okay? Then I'm going to go plus. And now I'm going to grab my next coefficient from Pascal's triangle, which is 3. Now work with your x and y, or x and 4 in this case. So x moves, the exponent moves down. So I started with 3, now I move down to 2. And 4 is going to move up. So start at 0, moves up to 1. Okay, I did that. Now plus, come to your next term in your Pascal's triangle, row 3, which is another 3. Again, x power moves down, so from 2 to 1. Y power, or 4, the power on 4 moves up, so from 1 to 2. Now I'm done with that. And then my last coefficient on Pascal's triangle is 1. The power on x moves down from 1 to 0. And the power on 4 moves up from 2 to 3. Okay? And now I'm done with that. So it should have had 4 terms, and I do. So now we'll just clean this up. I don't need the 1. I have x to the 3rd here, and 4 to the 0 is just 1. So this first term is just x cubed. Here, grab your coefficients, okay? So let's see, we've got 3 times 4, which is 12, and then I still have the x squared. For that next term, you've got 3 times 4 squared, right? So 3 times 16, which is 48, and then we still have x. And then we've got 1 times 4 cubed. 4 cubed is 64, so I've got 64. X to the 0, which is 1, so I don't need to write that. So that is my binomial expanded all the way in descending order. First pause on the screen, can you go ahead and copy the second part of example 1? All right, we're back. So a couple differences. Again, instead of just y or 4, now you have negative 2y. So I really want you to rewrite this actually as x plus the quantity negative 2y, okay? So instead of like a 4, we have a negative 2y. So I need to think about that as sort of the second term of the binomial, as it's a negative 2y, and this is all to the 4th, okay? So let's go ahead and first just grab the values from the 4th row. When I say row 4, it's technically the 5th row because we start at row 0. So it's the values of row 4. I'm going to force pause on the screen. You go ahead and just write those values from your notes so that you have them to you have them as guidance. All right, row 4 on Pascal's triangle is 1, 4, 6, 4, 1. So let's start there. So I'm going to grab my coefficient of 1, and then I'm going to take this term, which is x, and raise it to this power, which is 4. Then I'm going to take this term, and do be careful with your parentheses here, so you're multiplying a negative and not subtracting, and raise it to the 0. Okay? And then we're just going to keep grabbing values from Pascal's triangle. So I've done that one. And this power is going to, what, go up or down? Go down, and this power is going to go up, right? All right, so now my next coefficient from Pascal's triangle is 4. And now I've got x to the 3rd, negative 2y to the 1st. Done with that. And then I am going to grab my next coefficient, which is 6. And we will have, again, exponent goes down, so to the power of 2. And then I've got negative 2y to the power of 2 as well. Done with this. And then we'll grab our next coefficient, which is 4. And x is now at the power of 1. Negative 2y is at the power of 3. And then one more coefficient is 1. Exponent on x is 0. Exponent on negative 2y is 4. And that's always good news because you want to end with your degree again. Okay, so cleaning this up, anything to the 0 power is 1, so all I have for the first term is x to the 4th. Let's take a look here. I've got to be real careful with these exponents. So I've got negative 2 to the 1, which is negative 2, times 4, that's going to be negative 8. And then we've got x to the 3rd, y to the 1st. So I'm just going to put y. Okay? Working our way here. I've got negative 2 squared. So what is that? That's positive 4, right? Times 6. So I'm taking this there. That's going to be positive 24. And then I've got x squared, and my y is squared as well. In other words, make sure the square is going to everything in parentheses, okay? All right. Next I've got 4 times negative 2 cubed. Negative 2 cubed is negative 8. Negative 8 times 4 is negative 32. And this is x to the 1st, y cubed. And then my last piece here, this is 1, this is 1, so negative 2 to the 4th is positive 16, but I still have that y to the 4th. All right, if you need to pause and kind of soak it in, feel free to do so, and then we will continue. Force a pause on the screen. Can you go ahead and write this binomial and this term? Hit continue when you're ready to do it together. All right, so on some of your homework, instead of expanding that, because that would be a little bit ridiculous to go to row 11 on Pascal's triangle, it just asks you for one particular term, okay? So in other words, if you were to expand this, what would be the coefficient in front of this term, okay? So remember, a while back, we put that to find the coefficient, we could use Pascal's triangle, or we could use a combination where n is your degree and r is actually your power on either the x or the y. It would work either way. But also come back here, notice that if one of our terms, like your x or your y, has a coefficient in front of it, then that's going to affect the coefficient in front of that particular term as well, okay? So for something like this, here's what we're going to do. We're first going to start with that value from Pascal's triangle, which in this case would be, go to your degree, 11, choose, and then you can do either 6 or 5. You're going to get the same thing. If you think about your formula for a bit, I think you'll see why. And then you need to say, okay, but wait. There's a coefficient in front of the a term and the b term as well, right? So we want to raise the a term to what power here? The 6th. So grab your coefficient in front of the a term, which is 2, and raise it to the 6th. And then what do we want, what is the b term raised to? The b term is raised to the 5th, and what is your coefficient on b? It's actually -5, so be sure you grab that negative and raise it to the 5th power. Okay, and now I can actually just type that into the calculator just like that. Let's see if we can see both here. All right, so on the 84, you're going to go math, scroll over to probability. It is number 3. On Desmos, you can just do NCR. So I've got 11, choose 6 times 2 to the 6th, and let's be mindful of our parentheses here, times -5 to the 5th, and I'm getting that value. Let's write that. All right, -92,400,000 would be the coefficient in that whole expansion if I were to raise all of that to the 11th power, okay? All right, you try one on your own. Hit continue when you're ready to check. And we should have gotten 216. All right, y'all, that's all I have for today. I will see you next time.